Students, welcome back. Now we move on to the next part, but before that I would like to revise this portion that we had just done. We had divided elementary particles into boson and fermions, but we have not yet looked at which particles these are. So I would just like to mention that leptons are nothing but they are the electrons, which we write like this, and along with it we have the positron, which is the antiparticle of the electron, and we also have here the muon, which we have a positive one, and we have a mu minus out here. Then we have more particles. We have this is called the tau particle or the tauon. So we have a negative one and a positive one. And then we also have another light particle, a very important particle, that is the neutrino and antineutrino. So I just write it like this since I don't have space. So you see electron, positron, muon, antimuon, tauon, anti-tauon. Then this is what? This is a neutrino. This is the antineutrino. These all constitute leptons. So students, if someone asks you to write a short note on leptons, you can immediately write from here, from this chart itself, that what are leptons? Leptons are fermions, so they obey Fermi-Dirac statistics. They have a half integral spin. They constitute what are the particles in the family of leptons. These are the particles. So actually that's why it's so important to remember this chart, and I'm sure you'll remember this. And what about the nucleons? We already know what are nucleons. They are the proton, which is a positively charged particle, but then there is also an antiparticle called the antiproton. So proton, antiproton. Again out here we have the neutron, which is uncharged, and also we have another one, this is the anti-neutron. So you see the concept of antiparticle is also there. With every particle there is a concept, the antiproton should be like this, so the anti-neutron. So there is an antiparticle along with every particle. And hyperons, just now we had seen the number of different types of hyperons. We have seen the omega hyperon, then we have seen the lambda. This is the capital lambda, students, and you know this is also the capital omega. Then we have the sigma. The capital sigma is written like this, which is like the summation. And then we also have the capital Xi, which is written like this. So these are, you know, this small Xi is written like this, and the capital Xi is written in this manner. So these are the hyperons. And on this side we all know what are the photons and gravitons, and then we have the particles which are the pions. This is the pi plus, the pi minus, and the pi neutral. Then these are the pions. Then we have the kaons. We have written just now in the part 1 of today's class: K neutral bar, K plus, and K minus. So these are the particles. But then here I had omitted one. There's also a eta meson. So eta meson has also been discovered. It is a uncharged meson, and we know that together they constitute the hadrons. So if someone asks us about hadrons, we can write that what are hadrons? Hadrons has got so many numbers in the family. We have all these and all these, not all this one, the nucleons, the hyperons, like this. That means it's the mesons plus the baryons. So you can expand the whole thing and write in your own words like this. And they are strongly interacting particles. and we'll know what are strongly energetic particles in a few minutes from now. So we had already seen that the kaons, k-mesons and the hyperons, I have probably not told you the names of these. Yeah, this is the lambda hyperon, this is the omega hyperon, these are the xi hyperon, and these are the sigma hyperon. And why they are called strange particles, we have already seen. I'll not repeat it. And look at this point. After the discovery of strange particles, a new quantum number, because we have not at all talked about quantum number till here, a quantum number was introduced. It is called the what? It is called the strangeness quantum number. It is denoted by S. And kaons, and this quantum number is possessed only by strange particles. So, only strange particles possess the strangeness quantum number S. So these are the values. Kaons has a -1 value, lambda hyperon has got a also have -1, sigma hyperon has got a -1, xi hyperon has got -2, and omega hyperon has got a value -3. So this is one more information that I would like to share with you. Now another important information is that since we have talked something about decay mode, here we will understand what is a decay mode, because for all elementary particles can also be divided according to their lifetime. You see, proton, electron, neutron are said to be stable particles, because once an electron, the electron always remains as an electron. About proton and neutrino, this proton and neutron, though it was earlier thought that once a proton, always a proton. It's not so now. It also has a lifetime, but it has got a very big lifetime, and it does not decay on its own. Some nuclear interaction has to happen, otherwise it will not decay. So they are said to be stable particles. So elementary particles are also, some of them are stable particles, others are unstable particles, and they do decay. Now this lifetime of unstable decaying elements, you see if they have a lifetime about 10 to the power -13 seconds to minutes, then they are said to be semi-stable particles. That means if some elementary particle has got a lifetime, any elementary particle which has got lifetime lying between 10 to the -13 seconds to minutes. Minutes means what? More than 60 seconds. So you can say more about 10 seconds. Then you say that not 10 seconds, more than, definitely minutes means it has to be more than 10 seconds. So you see it's semi-stable particle. You cannot say them unstable also. But if the lifetime is even less than that, 10 to the power -23 seconds or so, then we say that they are unstable, and such particles have also been discovered. That means actually there are particle instruments called particle detectors. In these detectors, particles can be detected, and the particles of these kind of characteristic with so low lifetime has been detected, and these are termed as resonance particles. So that is one more thing. And now we talk about the four fundamental, because we have been talking about strong interactions without explaining what is a strong interaction. So I would like to move on to it. This is the four fundamental interactions. You see, all elementary particles, interaction between elementary particles consists of any one of these four actually, and no other force in nature has been found which is different from four of these. That means they have to be either gravitational or weak or strong or electromagnetic. Now students, among this, electromagnetic interaction is found to be very common and found to is very we know that it is the interaction between charge also like this. So this is the electromagnetic interaction. Now what is strong? Strong is the force, nuclear force of interaction between two nucleons, a proton and a neutron, or a proton and a proton, or a neutron and a neutron. So this is the strongest force in nature, which you know as the nuclear force. But then another type of nuclear force has also been discovered, which is called the weak force. It is also called the weak nuclear force. This is found in decay in electromagnetic, sorry, not electromagnetic, in nuclear decay phenomenon, and this is also strong is also nuclear. So when I say force, you know that in physics force and interactions are the same. So that means yeah, the fundamental forces, this is also called like this. And then we have the gravitational force, which we all know, which is the oldest, discovered the earliest. So it is the gravitational force, and that is due to the mass of a particle. Now students, there has been a scientists have always tried to unify all these four forces. They want to put them, all the force, on the same platform. They want to say that there is certain kind of, they try to unite all the four fundamental force, and this is called the GUT, or the grand unification of force. So what is GUT? It is the effort of the scientists to try to unify all the forces, but till now only the first three forces have been, it has been possible to combine, not combine actually, to treat them as different parts of the same type of force, and that is called that can be explained with the help of the Standard Model, and we'll have a glimpse of the Standard Model. Now first of all, I would like to talk about exchange particle. Now what is this exchange particle? Now to understand what is this exchange particle, I would like to talk about the electromagnetic interaction. What happens in an electromagnetic interaction is, suppose I have got a charge like this. We know that if I bring a charge near it, this second charge is affected by this. So at early times it was thought that, because you see, even without a bodily contact between both of them, either this is pulled towards it, or if I have got a light charge, this is pushed away. So this is something that we know, all of us know, and in mechanics we know that a force, this body, when without coming in contact with the second body, it cannot interact with this one. But then after that, gravitational force was discovered, and gravitational force, we know that we have a body here. Even if that body is at a great distance, it obviously attracts it. So it was We'll talk about it in the part 3 of today's class.